Good evening, everyone. Today we will discuss nucleophilic addition reactions to carbonyl compounds. Carbonyl compounds such as aldehydes and ketones. So the first one is ketone, and the second one is the common structure for the aldehydes. In previous lecture, we have covered the topic nucleophilic addition reactions of carbonyl compounds with HCN, Grignard reagent, water, and sodium bisulfite as well with alcohol. And I have also made the video with the topic the reactions of carbonyl compound with alkali metals, including aldol condensation and Cannizzaro reactions. These two topics have separate videos. You can search at my channel. So the today is nucleophilic addition reactions with the elimination of water molecules. Clear? So aldehydes and ketones react with a number of ammonia derivatives. Here, first of all, what is ammonia? Ammonia is NH3. So this is its pyramidal structure. When one of the hydrogen of ammonia is replaced with some other substituent, then we will call it its derivative. Clear? So this H can be replaced with OH, NH2, any other phenyl ring with alkyl group. Clear? So I have represented this group with Z, and Z may be any group out of these mentioned entities. Clear? So Z is the common representation of these groups. So look at this molecule. This is your aldehyde, as this carbon is associated with one hydrogen there. And I have taken one of substituent of ammonia, and it's Z. Z may be out of these OH, NH2, and C6H5NH, and this also NHCO, NH2 group. So these are the some common groups which can be represented as Z. Here. Yeah. So as ammonia, how ammonia will react with aldehydes? As we know, nitrogen has a lone pair, so it will act as a strong nucleophile. And the carbonyl center, due to the difference in the polarity of these two atoms, carbon and oxygen, that is, there is partial positive charge on carbon and partial negative charge on the oxygen. So this center will act as electrophilic center. So NH2 will attack on the carbon of carbonyl group because it is electron deficient in nature, because it is attached with the oxygen atom. When this NH2 will attack on the carbonyl carbon, there is shift of pi electron towards oxygen atom. Here, then it will protonated, and we will get this intermediate. This is tetrahedral addition product. As you can see in this intermediate, there is bond between carbon and nitrogen, and the O negative of this reactant get protonated as OH. Clear? Okay. So the next step is, as nitrogen has one more lone pair also, it can react one more time. So it will form double bond with the carbon with the elimination of this OH group, thus forming a double bond between carbon and nitrogen. When there is a double bond between carbon and nitrogen, those molecules are also known as schiff bases. Yeah. So as this reaction is reversible, because in this there is formation of water, water can attack on again carbon, and this bond is breakable. So Schiff bases are very sensitive towards the water. So in this reaction, it is must you should remove the water continuously. When you carried out this reaction, you should use some apparatus separately to remove the water formed in this reaction. Here. So the what is the another peculiar property of this reaction? We will discuss it in detail with mechanism. Okay. So one thing I have already told to you, it is reversible in nature. The second one is this reaction is catalyzed by acids. So the pH used in this reaction should be around 3.5. I will tell you later why the pH should be 3.5. Just first of all, discuss this mechanism. Then we have told you that the pH must be acidic. Acidic means the protons are present in the reaction. So the first step is protonation of carbonyl oxygen atom. This O will get protonated to form O positive H. Clear? Okay. This is the intermediate number 1, and in intermediate number 1, the oxygen carries the positive charge, which in turn makes the carbon electron deficient in nature. So by way of resonance, here, it increases the positive charge on the carbonyl carbon. As a result, weak nucleophiles such as ammonia or its derivatives can attack on this carbon atom. Clear? Okay. So we have added acid to generate electrophile. Carbonyl center here is electrophilic in nature. It is already electrophilic. But to increase its electrophilicity, the acid is used. Okay. The second one is attack by nucleophile. This is your nucleophile. It will attack on this carbon carrying positive charge. Clear? Okay. Now, as nitrogen will lose its electron and it has donated its electron to this carbon, then nitrogen will occupy a positive charge. So to neutralize its charge, then deprotonation will occur here. That is minus H positive. Okay. Then you will get this molecule. This is your molecule number 3, where there is single bond between carbon and nitrogen and the single bond between carbon and OH group. Clear? Okay. Now, so what is happening in this step? There are two steps simultaneously occurring. The another one is, as this reaction is conducted in acidic medium, this OH group get protonated to form OH2 positive. Clear? Okay. As well, this nitrogen will donate its electron to carbon. When nitrogen will donate its electron to carbon, then there is formation of a double bond between carbon and nitrogen. Another thing is that as the carbon can form maximum 4 bonds, when there is formation of a double bond between this carbon and nitrogen, the number of bonds you will see is 5. But when the bond is formed, the another bond is also broken. So as when the double bond is formed, there is removal of OH2 positive. OH2 positive here will act as living group. As we know, OH negative is not a good living group. OH2 positive is a better living group than OH negative. So here is the double bond formed, as in this case, in this at this intermediate, nitrogen have positive charge. To neutralize this positive charge, again there will be deprotonation from nitrogen. Clear? Then after neutralizing this charge, your final products will look like this. There is double bond between carbon and nitrogen, and Z is somewhat else, like OH group, NH2 group. It may be any group. Yeah. So this is the general mechanism when the substituted ammonia derivatives reacts with aldehydes and ketones. Clear? Okay. Now, our question is why we have used the acidic medium. Clear? So this is the important question. Why the medium used for this reaction is acidic. That is 3.5. Okay. So you cannot use two acidic medium also. because the ammonia derivatives being basic in nature will form their ammonium salt. Like when the medium is too much acidic, this NH to get protonated and it form its quaternary salt. So this is salt form. Now, due to absence of lone pair on this nitrogen atom, these ammonium salts will no longer act as nucleophile. When these will not act as nucleophile, then there will be no reaction. The reaction will not occur. However, if the medium is only very slightly acidic, means if the pH is around 5 to 6, okay, too acidic is the pH is 1 to 2, and in case of slightly acidic, the pH is 5 to 6. We cannot use both cases, too acidic and slightly acidic case. In case of slightly acidic pH, the protonation of carbonyl group will not occur. As I have already discussed the mechanism to you. In first step, there is protonation of this oxygen. If I am using the slightly acidic medium when the pH is 5 to 6, means there are low number of hydrogen positive ions. So this oxygen will not be protonated. Hence, the weak nucleophiles like ammonia derivatives will not able to react this carbonyl center. In other words, you can say the reaction does not occur. Therefore, to carry out such reactions, an optimum value of pH is needed. Usually, the pH of around 3.5 is maintained. Yeah. Okay. So this is the reason why we cannot use too acidic and slightly acidic medium. We need optimum acidic medium. Clear? So just a sec. All of these derivatives such as hydroxylamine, hydrazine, phenylhydrazine, and semicarbazide, both all of these react with both ketones as well as with aldehyde. So further, I will discuss how these derivative will react the aldehyde and ketone and what kind of product is formed and what are the names of the products formed. The first is reaction with hydroxylamine. Clear? In this, the Z part is your OH and this is your aldehyde, that is methanol. I have chosen simple aldehyde over here and the pH of the reaction is like 3.5. So as through general mechanism, it will attack on the carbonyl center, then further deprotonation will occur. Then after deprotonation, again, this nitrogen will attack on carbon and it will form double bond to form methanol oxide. Clear? When the reactant you have chosen is NH2OH, then the product will be named as oxime. Like there is double bond between carbon and nitrogen, but now nitrogen is attached with OH group. Then this product will be called as oxime. As the reactant you have used is methanol, then the product is called as methanol oxime. And another example is acetaldehyde. This is your acetaldehyde. The same reagent you have chosen NH2OH, then the product you will get is ethanol oxide. Clear? So the name is ethanol because the reactant is different from the above mentioned reaction. The next is propanone. The reactant is propanone and the product you will get, there is double bond between carbon and nitrogen with the elimination of one molecule of water and the product formed is propanone oxide. Clear? So this is the reaction with using reagent NH2OH, that is hydroxylamine. The next one is hydrazine. In hydrazine, the Z part is NH2. So when there is single bond between nitrogen and NH2 group on either side, that group is known as hydrazine. When simple methanol is subjected to react with hydrazine in the presence of acidic medium, then you will get this product. Yeah, this is your methanol hydrazone. Now, the reactant is hydrazine, but the product you will get is hydrazone. So, all of the products formed using this reactant, hydrazine, will be known as hydrazone, but their prefix will be different, as the first case is methanol. So you will write here methanol hydrazone, and here is ethanol hydrazone, because in this you are using ethanol as a reactant. In this you are using propanone as a reactant, then the product formed is propanone hydrazone here. So the product we get from hydrazine is hydrazone, in which there is formation of a double bond between carbon and nitrogen. Okay. The next one is phenyl hydrazine. Clear? So this is your ammonia molecule. When this hydrogen is substituted with NH C6H5, then it is called as phenyl hydrazine. In another way, in previous example, the hydrazine is NH2, NH2. When you will replace one of hydrogen with phenyl ring. Wait a second. NH2, NH, and another hydrogen is replaced with phenyl ring, that is C6H5. So this is your phenyl hydrazine. The simple one is hydrazine. When hydrogen is substituted with phenyl ring, then it is called as phenyl hydrazine. Same methanol, ethanol, and propanone are subjected to react with the reagent phenyl hydrazine in the presence of acidic medium in which the pH is 3.5. Then the what kind of product you will get, that will be named as phenyl hydrazones. So first one is methanol hydrazone. The second one is ethanol phenyl hydrazone. And the last one is propanone phenyl hydrazone. So ene is converted into on. So you will write the product like this. These all are the Schiff bases, as there is double bond between the carbon and nitrogen. The next is the reaction with the reagent 2,4-dinitrophenyl hydrazine. Okay, so this is your phenyl hydrazine. When it is saturated with nitro group at second position and at fourth position, then it is called as 2,4-dinitrophenyl hydrazine. Okay, so here NH2 is acting as a nucleophile. Again, it will attack on this carbonyl center, and there is formation of the product in which there is a double bond between carbon and nitrogen. And when this bond will form, it look as yellow or orange precipitate in actual when you perform an experiment. Yeah, so this reagent is also used for the identification of aldehyde and ketones. When there are three groups, one is aldehyde, another one is ketone, and acids. So you have to identify which is your aldehyde, ketone, and acid. In first tube, you have taken aldehyde, and in second test tube, you have taken ketone, and in third, there is acid. So aldehyde and ketone both will react with this reagent 2,4-DNP here, but the acids do not react. So in by this reagent is used for identification. So it is concluded from this reaction, because in this there will be formation of some kind of precipitates that may be yellow or orange in color. Yeah. So this is the one of the advantage of this reaction. This reagent is also known as Brady's reagent 2,4-DNP. This is its short form. 2,4-dinitrophenyl hydrazine. Bread is reagent. The next reaction is with semi-carbazide. Okay. So, what is happening? This is your hydrazine, NH2, NH2. Now, in this case, one of hydrogen of this nitrogen is replaced with CO NH2 group. Clear? So the product formed is semi-carbazide. So this is your reagent used in this reaction, and this one is the reactant, that is methanol. And as well, this reaction is also conducted in the acidic medium, that is pH 3.5, and the product you are getting is there is double bond between carbon and nitrogen. So from here there is elimination of one molecule of water, H2O, and the double bond is formed 1, 2, 3, 4. So on product side, you can also again label these 1, 2, 3, 4. So clear? Yeah. Now my question is over here, as in this molecule there are three different nitrogens. Their environment is different, as this NH2 is attached to carbonyl group, and this NH is attached with one side carbonyl group, on another side NH2, and this NH2 is attached only with NH group. But in product only, the nitrogen number 1 is reacting with this carbonyl center. Why? My question is, this nitrogen, the nitrogen number 2 and nitrogen number 4, these can also react with this carbonyl group, but these are not reacting. Yeah. So what is the reason? As the carbon number 2 and 4, these are involved in resonance. Look at the molecule CO NH2. This is your 1, 2, 3, 4. Nitrogen number 2 and nitrogen number 4. These are involved in resonance because they are linked with the carbonyl group. As the carbonyl have double bond, the nitrogen will donate its electron to this carbon, and there will be electromeric shift, NH2 N positive, H O negative, and NH2. Clear? Now this nitrogen carries positive charge, so it will not act as a nucleophile because it have no lone pair. Similarly, nitrogen number 4, it will donate also its electron to this carbon, and further there will be electromeric shift toward oxygen, and it will also form resonating structure with carbonyl group O negative, NH2 positive. Here, so this nitrogen have no free lone pair, so it will also not act as a nucleophile. Only the nitrogen number 1, that is NH2, it has free lone pair of electrons, so that's why it is reacting with the aldehyde and ketones. Yeah. Look at the product. Yeah, it is ethanol semi-carbazone. As the reagent is semi-carbazide, but the product name is semi-carbazone. Yeah. Okay. The next example is propanone. When it is reacting with semi-carbazide, then the product you get is propanone semi-carbazone. So when the reactant is changed, the prefix is used according to the name of the reactant, and the suffix will depend upon the reagent name. If the reagent is semi-carbazide, then the suffix will be turned into semi-carbazone. Either if there is ide or ine, it will be converted into O. Clear? So this was all about the reactions of aldehyde and ketones with substituted ammonia derivatives. So I have shown you these reactions with different reagents have been reacting with aldehyde and ketones in the presence of acidic medium. So the important question is the medium must be acidic in nature to increase the electrophilicity of the carbonyl center so that this nucleophile can attack easily, effortlessly to carbonyl carbon, and there is formation of a schiff base. So these reactions are reversible, so we need to remove the water simultaneously whenever there is formation of a Schiff base. So this was all about the nucleophilic addition reaction followed by elimination of a molecule with water. Clear? In next topic, we will do about reduction reactions, oxidation reaction, and halogenation with aldehyde and ketones. So thank you for watching my video. If you like the video, please share and subscribe my channel. So, and wait for the next video that will be on reduction reactions, oxidation reaction, and halogenation of aldehydes and ketones. Thank you.